कैमरा सारे से मिस
अच्छा ठीक है। Abdul, please do switch on your camera.
So my camera is not working properly.
अच्छा ठीक है। Hello Alvina, Assalamu alaikum. How are you?
Walaikum salam, sir. I'm fine, thank you.
Okay, that's good. How's the preparation going on, Alvina?
It's going good.
It's going good. Chalo, that's good. That's good. Okay. Okay, so okay. So let's start this class, everyone. So in this class, we are gonna start the human eye chapter. Like we are going to complete the human eye. So atmospheric refraction and the scattering of light is only left, right? So now let's do complete that thing. Alvina, please do switch on your video picture.
Yes, sir.
Okay. Okay. So what? Just a second. Chicken. Okay, so the first thing that we are going to discuss is the atmospheric refraction. So what is atmospheric refraction? ठीक है, atmospheric refraction is basically the refraction that occurs due to atmospheric layer of the earth's surface. ठीक है, so the refraction of light caused by the earth atmosphere having different layers. So due to this thing, atmospheric refraction occur. ठीक है. Next is we have layers with having different densities. So so that's why the atmospheric refraction happens. So each layer will basically deviate the light ray coming from the outer surface. So that's why we observe the atmospheric refraction. So the first thing that we're going to discuss in the atmospheric refraction is the twinkling of stars. So twinkling of stars is due to the atmospheric refraction of starlight. Okay, and the continuously changing atmospheric. Okay, so the continuously changing atmosphere refracts the light by different amounts. So when the light is coming from the far objects, so they refract a lot by the different intensities, and due to this, we feel that the stars are twinkling. Clear, all of you?
Yes, sir.
Yes.
Okay. So the starlight reaching our eye increase and decrease with different intensities, and such that we think the stars are twinkling, but they are not twinkling actually. They are just basically on the same place, and they are emitting the light with the same intensity. That is the basically the refraction that decrease or increase the intensity of the starlight. Okay. So next thing we have in our mind that why if stars are much more bigger than the planets, but still they twinkle, but planets do not twinkle. Why? The reason is that planets are not the sources of energy. They do not have their own light. They just reflect this sunlight. Okay? But stars are the luminous object. It means that they have their own light. Yes, everyone.
Yes, sir.
Any
Yes.
doubt?
No, sir, no.
No,
Yes.
sir.
Yes, sir.
Okay. Okay. And planets are much closer to Earth, so that's why the atmospheric refraction shift is not observable at all. Okay. Next thing is that the intensity of the light coming towards Earth's surface is very less, and brightness of a planet remains same, and hence it does not appear to twinkle. Clear?
Yes, sir.
Good. Now let's talk about advanced sunrise and delayed sunset. And such thing also happens due to atmospheric refraction. We can see the sun before sunrise as well as after the sunset due to the atmospheric refraction. Okay. So this is the figure. You can see this thing. The actual position is this, but due to the refraction, the sun appears to be above the horizon before sunrise as well as the after the sunset. Clear, all of you?
Yes.
Any doubt?
Yes. Yes. No, sir.
No, sir, no.
Okay. Good. Next is, we can see the sun before the sunrise as well as after the sunset. Okay. So next thing, so when the sun is slightly below the horizon, then the sunlight coming from the less dense area to more dense area is refracted towards the normal or downwards as it passes through the atmosphere. Because of this, the sun appears to be raised above the horizon when actually it is slightly below the horizon. The next is the time from sunrise to sunset is lengthened by 4 minutes. How 4 minutes? 2 minutes for the sunrise, because we can see the sunrise actually before the actual sunrise, that is 2 minutes, and we can see the sunset after the actual sunset, so that would be 2 minutes as well. So the day is lengthened by 4 minutes. Clear, all of you?
Yes.
Yes.
Any doubt?
No, sir, no.
Good. Okay, so this is all about the sky atmospheric refraction. Is there anyone who is having doubt? Do let me know.
No, sir, no.
Alvina?
No. No, sir.
Good. Next thing, so scattering of light. So let's talk about this is the last topic, scattering of light. So the scattering of light is the phenomena by which a beam of light is refracted in many directions when it interacts with a particle available in the atmosphere. Okay? So scattering of light depends upon the size of particles and wavelength of color present in the white light. So every color particle will be scattered depending on the size, right? How much they are interacting with the atmosphere, right, everyone? So if suppose smaller particles will refract the smaller, just a second. So smaller particles refracts the your uh, small wavelength, and larger particles will scatter the large particles. Okay, so these particles and water droplets are suspended in the air, so they are much more than the wavelength of range of visible light. So that's why they are going to scatter this red light. Okay, so this is the range of the human visible range, that is 400 nanometer to 700 nanometer. Okay, violet to red. Clear, all of you? Do remember these values. Next is the air molecules. Nitrogen and gas molecules present in the atmosphere are smaller than the wavelength of visible light. Okay. So the color of the scattered light depends on the size of the scattering particle in the atmosphere. Okay. So larger particles of dust and water droplet present in the atmosphere scatter the light of longer wavelength, or such due to which scattered light appears white. So what happens basically? So such in many cases they are they are going to scatter longer wavelength like red or orange. Okay. And in afterwards, in some scenarios, what would happen basically, the light will not scattered at all. Okay, so that's why we think the sky appears to be white in the afternoon. In the basically bilkul around 12 or 1 o'clock, you will feel that the sky is completely white. You might have observed this thing. Have you observed this thing? So there's a time when basically the sky appears to be completely white. No actual sky blue color is there. There is very slight blue color, but most of the time the uh, b- proper noon time in proper noon time, the sun appears to basically the sky appears to be a little bit white, more white as compared to blue color. The reason is that the white light is basically scattered more. Okay, instead of any specific color. Is that clear, all of you?
Yes.
Clear, Galvin and Alvina?
Yes, sir. Clear.
Good.
Yes, sir.
Next is, so the extremely minute particles such as gas particles or mist present in the atmosphere scatter mainly the blue light. Okay. Okay.
Yes, sir.
Afterwards, why sky is blue? The reason is that scattering of blue component of white light scatters by the air molecules that is present in the air causes the blue color of the sky. Okay. So when sunlight passes through the atmosphere, most of the longer wavelength present in the air do not get scattered much by air molecule because they are smaller in size. So that's why smaller wavelength, that is blue color, is scattered by air molecules all over the sky. Okay.
Yeah.
Next is, if Earth had
Okay.
no atmosphere consisting of air, there would have been no scattering of light at all. So no light from the sky will basically enter our eyes, and hence the sky would appear black and dark. Okay. In outer space, the sky look dark and black instead of blue color because there is no atmosphere, there is no sun to scatter the sunlight. So in that case, the sky appears black and dark. Clear?
Yes, sir.
Next is, danger signals light are in red color because red color can travel more distance as compared to any other color because it has having the longer wavelength. Okay. Okay, and it is not scattered by the fog or smoke particles. Okay. So due to this, the red light can be seen from very far distance. Is that clear to all of you? Below clear?
Yes, sir.
Yes,
Clear.
sir.
ठीक है, चलो जल्दी से मुझे इसका आंसर बताओ in the chat. ठीक है, so type the answers in a single message in the chat. ठीक है. Okay, Alvina. Galvin and Abdul, do let me know the answer. Hello, Sumaya. Assalamu alaikum. Am I audible? Okay. Okay, please do solve the question. Galvin, answer. Here you go. Sumaya, do it fast. I'm giving you 2 minutes. Okay, let me send the answer in the chat in a single message. Yeah. So Sumaya, answer. Let me tell you what is the atmospheric refraction of light causes the twinkling of stars only. Okay? Star appears higher in sky than they actually are due to the refraction of light. The star twinkles, but planet do not twinkle because stars. Okay. Stars are very far from us, but planets are nearer to Earth. Okay. Next is a light from the far off stars comes down toward the Earth and it bends towards basically a light from a far off star comes down towards the Earth. Okay. It bends towards the normal because density keeps increasing. Clear? Next is we can see the sun before the actual sunrise by 2 minutes, not 5 minutes, 2 hours, or 20 minutes. Okay. Due to atmospheric refraction, the sun light, the time from sunrise to sunset is lengthened by 4 minutes. Okay. The day is longer on Earth by 4 minutes because, tell me, the Earth has atmosphere. Because due to atmospheric refraction, the day is lengthened by 4 minutes. ठीक है? चलो जल्दी से इसका 1 and 2 का आंसर मुझे बताओ. आंसर बच्चों. ठीक है, ओके अब्दुल। सुमैया, अलवीना, गैल्विन, जल्दी से दो आंसर। ठीक है, अलवीना, गैल्विन, सुमैया आंसर। ठीक है सुमैया, देखो। So a person is seeing seeing an object closer to his eyes. What will be the change? The change would be the light. Oh, sorry, the focal length of the eye is increased. No, the maxillary muscles will contract. Yes, because the person is basically looking at the object with a constrained eye. Okay, the object is near to the eye, and the focal length would decrease because of the thickening of the focal lens. Okay, basically the eye lens. Sorry, clear all of you?
Yes, sir.
Okay. Next is which of the given option correctly depicts the light of sun reaching the atmospheric surface? So this would be you can see this thing, and the refraction will happen, right? So any answer from anyone? अच्छा second वाला भी दे दिया आपने, ठीक है. Yeah, ठीक है. So in this case, see this thing, what's happening with this? So which of the following, okay. So once the sunlight is coming, so it is basically bending, and here the atmospheric refraction is continuously happening. So this one would be right. Okay. Let me know the answer for the third and fourth. Okay, Alvina. Okay, Abdul. Okay, Sumaya.
Can you discuss the answers, sir?
Yeah, sure. देखो, which of the following is the brightest light? So as you can see, brightest light means the less amount of light will enter into the eye. So that's why the pupil size should be very small. Okay? Brightest light, the pupil size would shrink to small. Okay? Fourth one is basically the person is suffering from presbyopia because the near point as well as the far point is basically modified or basically not the normal thing. Okay? Because it is 0.5, it is 0.75. Okay? So in that case, the person should use the convex lens. So focal length is given to you. Power would be 2 diopter for the convex lens, that is for the near, and negative 1.33 for the concave lens. Okay? So it would be 2, option D. Okay? Clear? Let me know the answer for this one. Fifth one, sorry.
Sir, how did you know it was option D?
Didn't get your word. Could you please repeat?
How did you know it was option D?
Dekho. The person has said the near point is increased and the far point is decreased. 75 centimeter is very small for the infinity as compared to infinity. Or even though if you talk about 2 kilometer, 3 kilometer, it's very small. Okay? So in that case, the person is suffering from presbyopia. So for the near point, convex lens is used for hypermetropia. And for the myopia, concave lens is used. So that's why the option D. And though, देखो, यहाँ पे आपको if the focal length is given to you, you can calculate the power easily. Then you will match the options. ठीक है?
Yes, sir.
Yeah. Let me know.
कोई ले जाता तुम्हें फिर क्या होता हाँ? करने क्या गई थी नीचे चलो चलो कोई बात बिना बताए आती माफी आ जाओ आ जाओ आओ आ जाओ कोई किसी दिन तुम्हारा उल्लू बना दे वो ले जाएगा हाँ ले जाएगा बच्चों को ले जाएगा हम ना
ठीक है. The okay, okay. There you go. So when the person is standing at Y and the car is coming from X to O, it means that the distance is decreasing. So initially the focal length of the person would be high, or the high, because the object is far away from the person. But when it is coming towards the object, the person, so it would decrease. Okay. So and hence the focal length will also decrease, and the lens would become thicken, and the ciliary muscles will contract. So at X, the focal length is higher than O. Yes, it is right. Okay. First option is right. Second, the focal length is higher than at X. At O, the focal length is wrong. The ciliary muscles is at X, ciliary muscles is thicker. No, ciliary muscles are not thicker at O. At O, the ciliary muscles is thicker than at X. Yes, fourth one is right. So option fourth, one and fourth is the correct one. Okay. Is that clear to all of you?
Yes.
Let me know the answer for the ninth one. Take care. Okay, Alvina. Alvina, answer. What about rest of you?
Sir, done.
Done. Okay. Take care. Anybody left with the answer? Calvin? Sumaya, answer. The option would be B, because the video should be from the top. So that's why. Okay. Clear, all of you?
Yes.
आमना बेटा चलो शाबाश सुनाओ। अच्छा सॉरी हमसे गलती हो गई। आमना जल्दी 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 तो देना है। नहीं तो बेटा तुमने भी तो बैठी हैं आपको तो तुमने क्या